Okay, so I'm going to get to the solutions to present them. Here we go. All right. Okay, so here, right, so we have A is 1, okay? And I tell you that C is 4. So the adjacent side and the hypotenuse, those lengths are 1 and 4. That's given, okay? For B, the opposite side of theta, we need to figure that out. How can we do that? Pythagoreans theorem, right? Because by Pythagoreans theorem, A squared plus B squared is C squared. So in this case, we have A is 1, B is unknown, and C is 4. So you have 1 squared plus B squared is 4 squared. So 1 plus B squared is 16. So from here, we're going to have 1 plus B squared is 16. So we're basically solving for B now, right? You know, you just subtract 1 from each side. You get B squared is 15. And so that forces B to be the square root of 15. So this is what we get here. B now is the square root of 15. All right, that's really the hard part, because once you know all the sides, you can get the trig functions easily. For instance, what is sine of theta? Well, remember, by SOHCAHTOA, right, sine is opposite, right, divided by hypotenuse. You know what? Let me actually add that. I can do that. No, not there. SOHCAHTOA, right? The opposite side is B. The hypotenuse is C, so sine of theta is B divided by C. And B in this case, we just got, C is 4, that's given. So we get sine of theta is B over C, which is the square root of 15 over 4. For cosine of theta, right? Well, that's the adjacent side divided by C, which in this case is A divided by C. So we really didn't have to find B to get cosine. But in this case, cosine is A divided by C, which is 1 over 4, as you can see. Finally, tangent is the opposite side divided by the adjacent side. So B divided by A. B divided by A. So we got B. So in this case, it's the square root of 15 over 1. That's for part A. Are there any questions on that? Okay, well, let's do part B. So part B is similar. It's similar, except here we're given A and B. A is 2, B is 3. We have to figure out what C is, right? So again, we have A squared plus B squared is C squared, but I'm telling you that A is 2 and B is 3. So how can you get C? Pythagoreans theorem. So you have, let me get to the equation. Here it is. You have 2 squared plus 3 squared is C squared. So 4 plus 9 is C squared. So here it's actually easy to get C. C is just what? Well, C squared is 13. So C is the square root of 13. Okay, that's good. Now, what would sine of theta be? Well, sine of theta, right? Remember, that's opposite, which is B, divided by hypotenuse. Opposite divided by hypotenuse. Okay? Opposite over hypotenuse. So B divided by C. That's what sine of theta is. B over C. So in this case, we're going to have 3 over the square root of 13, right? B we're given is 3, and C we just calculated. Cosine, as before, is the adjacent side over C, right? Adjacent, right? That's the side next to it. That's down here, A. So cosine of theta is A over C. So in this case, A is 2. C we calculated to be the square root of 13. So cosine is 2 over radical 13. Oh, I thought I made a mistake. I did not. And finally, tangent's B over A. Okay? B over A. Right? B we got is radical, B we got is 3, A is 2. So tangent of theta is B 3 over 2, right? B over A, opposite over adjacent. Opposite over adjacent. B over 2, 3 over 2. So that's what we got here. All right. Really hope that made sense. Are there any questions on this? Because there's another problem I want everyone to try. Then we can always just move on to the next section. You know, again, I will post this, don't worry. The solutions will be posted. All right. So for the next one here, let me just share the file. Here it is. Here it comes. There it is. You have theta is an angle. We're assuming it's acute. So all we know about theta, the angle, is that it's between 0 and 90 degrees. Secant of theta, we're assuming is that a mistake? Actually, that's a mistake. Shouldn't be 5 over 3. It should be 7 over 4. Let me just fix it quickly. 1 second. Actually, you know what? Here, let me just